Hello, everyone. Welcome back to another Fireside Chat. This is our Fireside Chat 34. And today, what we would like to do is to talk about design up front. And this conversation was inspired by some internal discussions we had about we normally assume that design up front is a bad thing. And it's also known as the BDUF, right? It's the big design up front, as people say. But what triggered us was how much planning do we actually need to do, both in terms of business, in terms of planning our the work ahead of us, and also like the technical side as well. And also, there is a huge difference between working within a small team and working in a much larger organization where there are many things happening at the same time. But as always, I'm here with my colleagues, Mashuk, Jose, and if you're new to this channel, so we always talk about things that we want to talk about, things that we normally enjoy a lot. It's part of our daily lives as developers, as managers of a consultancy. So if you like those chats, subscribe to our channel, hit the like button, and also leave in the comments which topic you would like us to discuss. So, and we are live. It's good to see that we already have a few people watching us live. So that's very cool. So if you want to interact with us, just leave us some comments on the live chat. So cool, guys. Big design up front. So is it considered bad, and why is it considered bad? Let's start from there. Right, so let's just for maybe it's like younger developers or younger professionals, like why is this considered bad today?
All right, so I think I'll get this one, Matt.
Go for it.
You're normally the one who starts, right? So I think the problem with design up front is the big part, right? What you're saying is the big design up front is the big part. I personally think that there is some design up front that you need to do if you want to get to where you want to go. No, the problem is when you spend a lot of time designing and not a lot of time actually building the thing. Especially when there's a lot of uncertainty in what you're doing, because the fact that you're doing that at the beginning of the project, no, if you look at the project as a learning process, no, you're learning about the domain, you're learning about the system, you're learning about the solution, right? Is if you start designing what the solution looks like when you don't know anything, or at least when you know the least, chances that whatever you design is going to be wrong are big, right? And that's what I see as a problem with that, right? Like I actually believe that if you go down that route, is usually more on trying to reduce the level of stress. Oh, I'm going to plan everything, I know everything that's going to happen, etc. But that rarely is the case. I've never seen a project like, and I work in a lot of projects, but I've never seen a project that did the traditional analysis phase, etc., and ended up being exactly as it was predicted, right? Like as it was designed initially. So yeah, that's what I think. Like for me, it's not so much the problem with design up front. It's more about the big part. How much of that design should you do at the beginning, instead of just finding out what the solution is and trying to get in there.
I've got a slightly different take, by the way, on this.
Okay.
In terms of why it's considered bad. Big is relative, right? Big.
Okay.
Big compared to what, right? But in terms of why it's considered a bad thing, I think it's a bit for knee-jerk reaction as well to some level, because before Agile there was waterfall, and in waterfall world, there were distinct stages, and one stage was design, right? So you kind of, you and let's for now, for the purpose of this, I'm gonna kind of planning and design. There's a project planning aspect, and I'm sure we're gonna talk about as well. And then there is the design. Assuming you have all the the plan, or you understand the problem domain, and you're trying to design the solution. Yeah. And in the waterfall world, they try to understand everything, and then they try to design everything before they implemented everything, right? So the feedback loops between the design stages, planning even, and the implementation stages and verification and so on were huge, right? So, and that's obviously bad, because the problem with big upfront design, or design as a distinct stage and a very large stage, is that, like all plans, no plan survives the first contact, right? But that does not invalidate the design effort. What the problem there always was, that there was no feedback into evolving the design, and often people ended up uh, working to a particular design that they already knew was not suitable for the problem given what they were doing. So
Just
I think that is a bigger problem with design up front, or that
one
was
thing.
considered.
One thing, when we're talking about design here, what are you putting in there? Like we're using the word. What are you putting in there? Are you putting architecture? Are you putting classes? The interaction diagrams? Like what is it that you
this is what
encompasses the design?
It's a
yeah,
very
this
good
is the question from Laura.
Yeah.
Yeah, sorry. This is a question for Laura. Like she was asking, like, what do you mean with design at this stage? Software, pattern, architecture, everything.
It's a very good question, actually. And when if you take the context of the kind of waterfall world, and even rational unified process that had quite distinct stages, although it was meant to be a bit more iterative. It's all the way from kind of high level architecture, like different systems interacting with each other, to class diagrams that were created to represent different modules, and the structure in classes and methods within that module as well. So that's why kind of UML tools became quite popular in that era as well. So when I'm talking about design, big upfront design, I'm talking about that whole thing taken to that level, right?
Yeah, I agree.
This is actually. No, I was just saying that this is where I actually, when I started, I did a bit of waterfall, but then most of my projects were already using rational unified process, and in there we had, if I'm not wrong, were 9 different types of diagrams. And we had like the state-based diagrams and behavioral type of diagrams. So we had sequence diagrams, but we have class diagrams, we have deployment diagrams, we have all sorts
that's
of.
more UML than rational unified process per se, because rational unified process was more related to the kind of iterative, the inception and design.
But then we had those diagrams that we had to produce, and then we had like the UML was the modeling language, if you like, used in those projects. But like, just going back to the Laura's question, was like, back then we would design everything up front, from all the way to high level architectural concepts all the way down to class level. And there were even like tools that would reverse engineer diagrams into code, or vice versa, right?
Spit out the code.
Exactly. So we would go from diagrams to skeleton of classes. And
I wrote generators for rational rows that would create the classes based on the UML.
But just to center this discussion, like, so I think that it would be good just like to bring more towards the current days, right? So we know where we were coming from, and basically like the reason that design upfront became well, a lot of people don't like that it became a bad word in a way, was because we overdone it in the past, right? Or overdid it in the past. So, but like if we bring that to today's world, that is more agile, iterative, is there a place for design upfront, and how much design upfront would be needed? And but before we even say, like, it's like, what kind of problems that we have when we have the opposite? I think probably
exactly, because this is the thing. Okay. We overdid it in the past, and we're overdoing it today.
Exactly.
That's what I mean by the knee-jerk reaction. We've gone the other way.
So we went from big design upfront to no design at all. right? So, and I feel that Agile really drove that, let's just keep iterating and stuff. And quite often, like I like to say that after so many years with this very short-term view of very small iterations, one after another, we as an industry are losing the ability to design. And the question here is like the no design at all, or just-in-time design, as I prefer to call it. Is that a problem with it? So what do you guys think in terms of how we do things today, where teams just iterate
Well,
and have a short view?
I think there's a fundamental problem with this, right? It's the material that you're using when change needs to be uh, when change needs to be frequent, right? So you need a more malleable material when you are trying out things quickly. So actually going straight down to the code, in my view, if you kind of start going down a particular road that you've designed, it's very difficult to then come out of it. You've introduced a bunch of interaction abstractions. They're all interacting with each other. You've got tests. Hopefully you've written good tests. More likely that they are pouring concrete all over that thing to be kind of bringing it all more and more difficult to change. And you don't no longer think at a different level, and you no longer uh, evolve the design quickly when you don't know enough, right? So my personal view is that actually just going straight to the code when you got a fairly large problem to tackle is in fact as bad as the other end, where people were spending months actually just staying in the abstract world of boxes and arrows, right? So I think there's a big problem with this, because it actually you kind of solidify certain areas that need to evolve much quicker and may evolve better on paper than they would in code.
And
So there is definitely a problem with just going down to coding rather than thinking about, even if it's just a bunch of boxes and arrows, and quickly trying to understand what you're trying to create at different levels, right? If you don't do that and just go to code, I think there is a problem there.
and that's even, it gets even worse if then you don't have the skills to be able to evolve whatever it is that you did into that, right? Like the whole refactoring aspect, or refactoring to patterns or whatever, like that already makes it even worse, because then it just becomes patch on top of patch on top of,
And even refactoring at what level, right? Often people say, oh yeah, refactor, but only refactored at the class level, right? But what about the module level? What about the higher levels, right? So refactoring becomes more and more difficult the higher up the levels you go, if you already have a lot of code to deal with.
Yeah, I think that this is also related to what Laura was talking about, like the different levels. Because I feel the same way. I'm not a believer that we can apply the Big Bang theory for code. For example, you start with a very small, tiny class, and you start TDDing that small, tiny class in the middle of your domain, and all of a sudden that expands to become a enterprise system, right? So I'm not a believer that, although theoretically possible to do that, this is probably one of the most inefficient way of growing a system, right? So I think we need to distinguish the kind of environment that you are in. One thing is like you are writing a piece of code alone or with a small group of people, maybe a pair, maybe 3-4 people, and you are exploring, you are just trying out a small thing. That is one kind of scenario. The other scenario is like you are working on a much larger platform or product. You have multiple teams in parallel. There is a lot of investors or different stakeholders. So a lot of people collaborating in many different ways. So doing that with absolutely no planning, just every single developer from different teams trying to do small iterations with absolutely no vision, no high-level guidance, I think that is a huge mistake. Is that's why we still have a lot of bad systems being written, even when they are using agile methods today. Because like you can iterate in small iteration, but if your vision is limited to 2 weeks or 1 week, and you have a lot of people with very short-sighted vision, coordinate all of that, you end up in a big mess, because some of the decisions, mainly when you're talking about architecture, technologies, parallelizing, working across people, the kind of investment that is needed also to create a system. If you're going to do cloud, if you're going to buy an off the shelf or integrate with a CRM or so, all of those kind of decisions, like larger architectural decisions, they cannot just emerge from
Is it
a small
um,
class.
I think it's is it Martin Fowler that has, architecture is like the decisions that are hard to change afterwards, something like that. I don't remember what the
Mm-hmm.
exact phrase is, but
Yeah.
I completely agree with that. And for me, the whole how much planning is needed, to some extent, it goes in levels. Like at the beginning of the thing, you need to understand, you know, what shape it has, so to speak. Like like big boxes, like this part here is going to deal with eggs, no, and this part is going to deal with no, and kind of understand the at least in a broader sense what the thing is. That's not a lot of planning ahead. You can get that in a drawing board, no, whiteboard, pretty quickly, and put it to the test. So that's something that needs to happen at the beginning, and also choosing, so there are certain things that you can choose, or you decisions that you need to make from the beginning that are difficult to change, but they're quick to be made at the beginning, right, without going into too much detail.
Yeah, and
But when
you
you
need. No, sorry, go on. No, continue, Jose. I
no
thought
no
you were
but
done.
but if you don't have that picture of how everything needs to look, at the macro
Fit
level,
together.
then exactly the whole picture, then it's very difficult, when you go and start with your class, etc., to know where you're going to end, right, and where you need, where certain responsibilities lie, etc. And that, I think, is the mistake, right? Like, going into the code without having that picture, recipe for a disaster. If you do, at least you get some resemblance of cohesion between the systems, no, that then you can kind of refactor into proper design. That's my impression.
It's actually, I was thinking exactly that I had there is there is a picture that Christopher Alexander, who sadly died last week, actually, or this week earlier. He talks about complexity within dependent forces within the system, right? And basically what we call that coupling and cohesion. And you mentioned that. And the thing is that, if, as Sandro said, if you start from the minutia and you start building this thing out, you haven't decided where the modules are. The modules basically, they provide the boundaries where you have relatively low coupling, right? And within it, you have high cohesion, which means you have high coupling within that module, right? But if you do everything without creating these boundaries or having some sense of these boundaries, what you're going to do is everything is going to be kind of coupled in a ad hoc way. And because they just need to be, this thing needs to talk to that thing over there, and you make that direct connection rather than through a well-defined boundary. And when you don't have those boundary defined, then to define them later on, and then but and then evolve your system so that they represent that kind of evolution, it becomes really difficult, right? At the paper level, at the design level, at the boxes and arrows level, you can create a lot of these things and start reasoning what belongs there, what belongs here. This, the kind of domain driven design and all these things come to mind, right? You can already start reasoning about your models, and you can change them at will. But when they start becoming enshrined in code, it's not as easy to change, right? So
Yeah.
that's why. Sorry, go on.
No. Sorry, I thought you were done, Mash.
No, I was just gonna say, and that's why, like, creating code without even thinking about design makes things very, very difficult for you to then evolve to something better.
Yeah. So I think that a big, an important point in here is to which level do you do those things, and how far you go with those things. So, for example, having a general picture, I think that is quite important. So, even if you are working on your own, and when believe me, like I had my own startup way before Codurance, and I made loads of mistakes. And one of them is just like not having a much bigger picture, both in terms of business and technology. And so like, okay, like, fine, I'm working with my own thing alone, but you need to have a view. Unless that you are just having fun on your own, that is okay. But like if you're really trying to make something commercial, that you have an investment and you need a return, either yourself or someone else, you need to have a plan. And the mistake, I think, is to go too low level in that plan. First of all, certainly don't need to go to the class level if you are trying to build a big project, a big product. But what Mesh was saying, for example, having boxes and arrows, maybe like someone in the chat now, I think that, who was it? I think that Javier Chacana mentioned domain-driven design. So having an idea of what are the bounded contexts do I have? What are the core areas of the system that I have? Who are the main actors that are going to be using the system? Do I have one type of actor or do I have multiple type of actors? What do they need from the system? What kind of things change together? What things should be changed in isolation? How easily can I parallelize work? Because for me, one of the big things about having some planning up front, and that includes business in terms of what features do we build next, but also technical design in terms of how we are going to build those things. One thing that is important is how much work can we parallelize, right? So how much work can we keep independent from each other? And these kind of things is not expensive to do up front. Because as Mesh said, just boxes and arrows, a whiteboard. We don't need to go down to the level of classes or methods. It's just boxes and arrows. This helps us to validate what we're trying to build, decide where we're going to start from, what should be contained in each area of the system, who is going to be working on that, because some of the systems also have a different level of expertise as well. I think that in that book, what is it called, Mash, that we teams topology. Team topologies is a great book, by the way. So like, for example, it talks about what is it called? What's the name? Specialized subsystem, something like that. But for example, depends on which system we are building. Different parts of that system, they need a completely different type of skill set or technology. If you're mixing AI or mobile, or if you are deploying parts of the system in a TV box or something like that, you need to have that vision. You need to understand who needs to work where, right?
There is a question by Anthony here. Like, when we talk about design, are we talking about the whole project or a particular or a single service? And I in my view, it's both. In fact, one thing to talk about, yes, you need the higher level kind of boxes. You know, if multiple teams are working with each other, you got a very complex system. You need to understand what goes where and all those kind of things. But even within a particular service, let's say, that is within a particular team, you still need design, because you need to communicate an intent to other people in your team, because they're also working while you are working, right? So if you say, well, design is emergent, they're all going to come up with their own emergent design.
What else emerges? Chaos.
Chaos, exactly. And that is chaos, because if no one knows what the other is doing within a team, that's not a team, right? And they're not going to be able to work together. So design is absolutely essential, even within the context of a service. And I'm purposefully not using the word microservice.
No, because this is there's another aspect to this, which is when I was talking about the big picture and so on, we do inceptions and we do discoveries and all these things to sort of scope out the amount of work that needs to be done. And this is something that happens in every organization that builds software, or should happen in every organization that builds software, whether you're a consultancy like us or if you're building a product internally, right? Like, you want to know, what is this going to cost me, right? Like, what is the size of this? How many teams do I need working on this thing, and so on? And those kind of questions,
how much can I do in parallel, or I need to serialize,
or I need to, exactly, right? So those kind of questions, by having the big picture, you can better estimate, let's say, right? Like, and that's a different thing, no, but you can do better guesswork, let's say. Yeah. But if you don't have that, it's very, now the issue sometimes is that is very linked to stakeholders, deadlines, budgets, commitment. No, and it's not something. And I think this is coming from the agile world. Going to the extreme of, no, we'll just write code and work on the right thing, and then we'll deliver value. We'll deliver value. Yes, but that's not the way that a business works, right? And people tend to run away from that commitment and tend to like avoid making the decision, especially on the development side. So it is needed, but it's not very comfortable to, because you're making decisions and you can make wrong decisions. I've made you mentioned the startup before, and I was laughing because I also have lots of lessons learned from previous companies that I've started. So from picking the wrong technology to all sorts of shit, right? So, and then having to deal with it, and then knowing that it's the wrong technology, pushing forward, things like that. So yeah, it is there. It's linked to having that big picture, is trying to answer as well other questions that don't necessarily need to go into the detail, right? It's more on the business side than on the technical side.
Yeah, like I'm looking at the chat here. Domicio had a point in here. So he was saying, like, you can talk about components and modules without bringing microservices into the picture. Microservices are a way of deploying a component. The most important thing is that they are isolated, in my opinion. So I would like you to tackle this one, because like when you are doing this exercise, these boxes and arrows, as Mesh said, and you are trying to define the high level bounded context, the actors, how they interact with the system and stuff. Quite often, what you will feel, what we will see is the degree of uncertainty that you have in some of those bounded contexts. And also, like, sometimes there will be areas of the system that you need to build that you understand very well, or at least you don't foresee any difficulties in implementing. While there might be a few areas that you say, look, this is, for me, is a question mark. I have absolutely no idea how we're going to tackle that. We're going to use a library, a product, or whatever. There is a big question mark. And there's also, as we are trying to separate those different modules, given the different criteria that we use for that, we can even talk about that a bit. But like, you don't know, for example, if you can have an idea of how talkative those different areas of the system are. For example, if you have two areas, A and B, how intertwined are they? Do they change together? Do they talk to each other very often? And if you are not quite certain, going back to the microservices question, like, you might make those decisions given the degree of certainty or knowledge that you have. You might say, you know what? These two areas of the business is very safe for me to keep them completely separate and have completely separate teams working on it, and we create an API in the middle. But there might be areas of the system that at that point in time, we are not quite so sure. So maybe it would be worse, you know what, let's put those 2 or 3 bounded contexts within the same deployable and wait, start iterating, let's see how they evolve. And then at a later stage, we make a decision if we remove one or more bounded context to its own service. But this exercise of doing some analysis up front is also important for that. And I remember, like, some of the e-commerce projects that we worked on in the past. E-commerce, they follow some very standard rules. For example, I know that my payment area should be decoupled from how we do catalogs. For example, we should not have them in the same program. It would be a safe bet in keeping them completely separate, in separate bounded contexts, separate services, and have different teams working on them, right? But if you say within payment, We have fraud detection. We have payment gateways. We might have a question mark in there. Oh, how are we going to do fraud detection? How are we going to do all the multiple payments that we might have? How are we going to deal with the PCI compliance if we are storing credit card data? So that at the very beginning of the system might not be so clear. If you can further break down the payment area, you might decide to say, you know what, let's keep everything together. We know that there are those bounded contexts and sub-contexts, but let's keep them together. Let's put a team on there, and we keep evolving, and then we defer that decision. But this decision up front is quite important. It's deciding how many teams you can have.
It's so important. Sorry.
Go on.
No, just a quick thing. It's so important that a lot of times, when you're not sure about those things and you make the wrong decision, you end up with the distributed monolith kind of thing, right? Like if you're not sure, but you still split things because the rule of thumb is everything needs to be a different service, no? And you don't understand very well your domain, or you don't understand very well the context, and then you're splitting things, and then you're creating more problems for yourself by introducing complexity that is not needed. So it's also very important to understand what the big picture is without let's say focusing too much on the details, and figuring out the details as you go. And the important thing is having the tools, and this is what I was referring to also with the refactoring and stuff like that, right? It's like having the tools to be able to change things when you need them to change, right? So if you're putting a lot of things together, have them well structured, so that if you need to, then you want to break it out into a different thing, then you can do that as well. So there is some forethought and planning that needs to happen in order to do that, right? Like you are constantly going back and forth into, hey, this is the big picture. Yeah. Oh, how is it changing? No, like this is what I'm doing now. If we go this route or this route, would it be better if I keep it like this or if I keep it like this? No, and having the tools to make those changes as you're going along, and that's quite important, because the architecture is going to emerge, so to speak. But if you don't have the tools, then it's not going to be the architecture that you want to emerge, right? Like it's going to be something else.
There are degrees of separation, basically. I mean, you look at you can separate things. Even different lines of code are a degree of separation, all the way through methods or functions, to classes, to packages, to modules, and then to deployment units, and to systems, right? And at each level, there are two major things. One is that at the lower levels, it's easier to move things around. At higher levels, it's less easy, right? To move things around, to repurpose things, right? So that's one thing. The other thing is that at lower level, the interactions are specific, and at higher level, they need to be general. So you should think about architecture is basically trying to hedge bets, right? So when you talk about high-level architecture, when you talk about a contract that you cannot change too often, you make that contract as general as possible, and that will help you with the change. And at a lower level, when you can change things really quickly, you make the contracts as specific as possible, because that will help you change quick. Right. So the decisions are different as well at different levels. And this is the reason that you need to be careful when, as Sandra was saying, that when you are unsure about certain interactions, when you are unsure on where the boundaries should be defined, what things need to live together and what things need to stay apart, when you're unsure, you keep it to a point where both you are dealing with really specific things and things that are very quick and easy to change in terms of their responsibilities.
Yeah, I would like just to. I like the how you said, Mesh, that architecture is about hedging, or design is about hedging bets as well, right? So we are trying to cater for a few specific problems, and just try to summarize, like, so that we can move on with the discussion. Like one of the advantages of doing some design up front, and by the way, design up front, we are not talking about going all the way to the class level. We are talking about very high level strategic design, understanding everything that needs to be built. So there are things like leveraging technology. So for example, would we be leveraging the cloud, for example, for our deployment and production environment? Would we be leveraging a product, a CRM, or something like that? There is also an aspect of how much can we do in parallel, right? So how much parallelization, how many teams can we have working separately and autonomously? Or what do we need to serialize? So because this design upfront also helps us to say, look, we cannot start working in B if A is not built yet, or it will be very difficult for us to do this way. So there is a certain order that you prioritize according to that analysis, if you like, not only design, but the full analysis. But there was a question from, where was it? From Muhammad. He had a very interesting question that we probably could tackle. He says, like, what derives system boundaries? Is that the team structures? So this is an exercise that we do a lot in our discoveries or inceptions for projects. Defining those system boundaries is very complicated. It's more an art than a science. And there is not a single perspective. What we learned, Mohammed, was that there are multiple perspectives that you need to have. One, for example, that we call is the different actors. For example, how many actors do we have interacting with the system? Are they different? For example, some of them are external, some of them are internal. I'll give you, like, maybe just to clarify the example. Let's take a CRM, and this is a real case from a client that we had in the past. They were an online fashion store. Yeah. So, for example, they had some users that were just normal buyers. They would go to the website to buy clothes. That is one set of actors. But they had some users, internal actors that we call, that were responsible for creating a product. So which clothes would be sold, right? Which clothes they would manufacture, and they would be available to be sold in different markets. So that is a different type of actor. Then there was a type of actor that they were the fashion experts. They would take the whole set of products and they would create the catalogs. So, for example, the summer catalog in Spain was different from the winter catalog in Brazil because we are in different hemispheres. So, given the same product base, different experts would create those catalogs, or whatever, which product would be available in one country would not be available in a different country, maybe because of the costumes, the culture of the company or the country or whatever. There were price specialists, people that were just specialized in price. They sold products across almost 100 countries. So this is just a few examples. I'm keeping it that simple, but I can go on forever in the list of different actors that they had. So each one of those actors, they need a different thing from the system. So this is one single perspective of dividing the system boundaries. Another boundary is data. Who owns data and who needs data? And owning data means who can change data and who needs to consume that data, right? So the example of the fashion experts, they need product information to create a catalog that would be specific for a country. So they own catalog data, so they can create a subset of products that will be available for a period of time in a country, but they don't own product data. That are all the products that are manufactured by that company. So that understanding of who can do what also helps with the context. There is also an element of security legislation. For example, BPCI compliant. If you are holding data that is sensitive, that cannot leak, and they need a higher degree of security or compliance, that is a separate, more technical requirement that also helps you to isolate data. So also what changed, another perspective is rate of change. What changed together, what changed separately. So this is another perspective.
And what
So
changes more often? Yeah, I mean,
exactly. So
there's
all
many
of
ways in
that
which you can.
are
But you know what,
examples.
Sandro? The thing is, you're describing the ways that we would look at it, and we would try to find what the best way to, let's say, split the streams of work would be. But in most organizations, that doesn't happen in that way. Like there's and this is part of what we bring in, no, like that look of, okay, so it really makes sense. It really makes sense to do it this way or that other way, no, and you have all of these options.
Mm.
Most of the time is, teams, components. That's what I see. No, like we own this component, but changing things in this component or in this set of components doesn't really affect the end or give you the end value that you're looking for, right? And it happens a lot like that, right? Like the structure of the organization kind of sets the divisions in the software, no, the Conway's law in this case, right?
It depends on how the components have been sliced through as well, right? To talk about that kind of vertical aspect, that the components, they can be based around capabilities or based around certain groupings of features, right? So which way you go, so that you can provide kind of end-to-end value to the customer, rather than be dependent on lots of other teams in order to create this end-to-end value. And that's where things go wrong, when you have to do that. And that's why, in the team topologies as well, you've got this kind of feature teams, but you may have complex subsystems that are
Complex
more
subsystem.
more
That's the
I'm
name.
not even still not sure if that's the right term, Sandro, but I think
I
it's
think it
closer.
is. Like that's what I remember. Complex
Okay.
subsystem.
But yeah, so that's, it's basically how you divide, right? So you have to, basically what you're trying, even with the teams, and I think it is important to consider teams when you are dividing systems, because what you are trying to do, teams are like software systems. You're trying to make them loosely coupled and cohesive,
High
because you
cohesive.
understand
Yeah.
that they the more they have to interact with other teams, the more synchronization that needs to happen, the more complex the organization gets, and consequently, the more, of course, the complex the systems are as well. So you're trying to kind of create that thing, and yes, when you are dividing, or understanding all these different responsibilities around who owns the data, what are the regulatory requirements, what changes with what, because all these are aspects that you consider. I was Mohammed Sufyan asked a question around, and I love the term that you have. If your systems are already in ginger shaped, and I thought maybe that was a typo, but I don't think it's a typo, right? It's it's actually a real. If you think about it, that's what it means. The things are just kind of slapped on top of each other.
Clarify that to me, like ginger
A
shaped.
ginger is, if you think about, what does a piece of ginger look like?
Like a
So
ginger house or a
No, not a ginger
instead
house. The root ginger itself, right? It
of
has
okay.
modules on top of modules, right? Kind of growing in all sorts of different directions.
mhm. I
Okay.
see. I
so
see.
so
I never heard
basically, the
that
question
before.
is, like, if the systems is grown in every which way, and now you start thinking about boundaries within that, and how do you do that? And that's a difficult problem indeed, but there's a lot of strategies around it, right? You have to, first of all, go back to the drawing board, and this is again the big up
What is the big
design up
picture?
front.
Where do you
That's
want to go? Like
yeah, exactly. What's your vision?
in general terms, where is it going? No, and this relates to another question that Anthony was asking. No, like if you advocate on not making technical decisions, no, at that level and so on, and that this is precisely that. Okay, so you can say, hey, we need to move to the cloud, and not have to choose which cloud provider it is that you're going to be moving on at that stage, right? Like once you understand a bit better, you can make those decisions. You can even have multiple cloud providers at the same time, depending on what you need, right? But that is the idea. But you need to have a direction of where you want to go. Without that, and I think, to the question that Mohammed was saying, it's ginger shaped because there was no direction that people could follow. Because if people have that clear direction, even if they're using different technologies, even if they're using, different, if they're organizing the code base differently, it sort of goes in the direction that you want to, right? And then you can you can shape it, or mold it a little bit. The problem is when everyone's going in a different route. That is a big problem, no? Especially if they're all trying to solve the same problem, different ways.
Yeah, so I believe that from the tone of the conversation, I think that we all think that a good degree of design up front
Design
or
up front.
planning up front is needed. I think that we also agree that at which level it should be, because I think that what is quite important here is that every activity that we do should have a purpose, right? We should be trying to solve a problem. So if you are trying to do some design up front, we don't do that for the sake of doing it. We do that for this because we are trying to solve a different problem, as I mentioned before, like we are trying to plan who can work in parallel or leverage technology and so on and so forth, everything that we discussed before. So we should just do enough to answer those questions, either to create a direction, either to realize which technologies we should use, how we're going to split our teams, what we're going to do in parallel. So that is always the goal. We should have a few questions that we want to answer, and the level of design that we do should be just enough to answer those questions, and not precisely answer, at least to give us enough to move forward. We don't need, we cannot, because there's always the danger that once we answer a question, we have two other questions at a lower level, right? So we need to also calibrate, okay, do we have enough to get started? And now that we have the teams working in parallel, or we have our plan of attack, if you like, we can start moving and then leave all those lower level questions to be answered by the different teams and so on.
On
Right?
that point, there's another thing. Like, you don't have to answer the question there, but you can put in place experiments to answer the question, right? Like, then you can go and say, okay, why don't we do a spike and figure out, I don't know, which component we need to, let's evaluate this and this, right? And see, which one we want to take. No, and you can start taking steps into increasing your knowledge about what the best decision would be, right? And that, I think, is also something that people miss. They make the decision at the beginning where they don't know anything, no, and then even if what they're seeing, is telling them otherwise, no, that's they're not changing it, no.
Yeah, and this
Because
this is the problem, as I mentioned with waterfall, right? Because there's only one design stage. You just got the designs that you kind of have to deal with. Basically, there is another element in design, right? Somehow people think that actually design is a separate thing from writing software. You are writing software even when you are writing it on a piece of paper, right? You're always writing software. You're using different mediums in a way to design. You design at a high level, you help that guide the lower levels, but then you have to come back up. Otherwise, you are then stuck. You have to have the feedback and then again design at the high level, evolve the design at different levels, because it's conceptually you have to constantly go down into the detail and come back up into the higher levels, right? This is how art is created, right? Like the person, they're writing, doing that small brush there, but they're constantly looking out to see where the picture is now, right? And going back down into that. And that is in effect design. And so is software. Your medium is different and you have multiple mediums, right? But you have to keep coming up and going down, and you have to keep these iterations going and not
but
just get stuck in one place, basically.
but you know what Bertrand Mayer would say? That happens because there is a separation between your design and your code, if you were using design by contract, your code will be the design. Therefore, there's no mismatch between the two, right? So there's that aspect as well of the limitations of the tools that we have,
Exactly.
no,
The
in order to
malleability of the
represent,
tool.
exactly,
Yeah.
to represent the big picture and the detail at the same time, no,
Yeah.
and yeah.
I would like to just to like conscious of time. I would like to move to another area, but before I do that, I just want to say, Emmanuel, I saw your question. Like you asked, like what would be the strategy to partition equipment, and that they were subsystems based on this overview. I'm not sure if I fully understand your question. So if you want to refine that a little bit, then we can address that. But while you do that, one of the questions that I had here is who should do that design up front. So for example, as we have more people involved, because like also like we have
The art,
also
this is the architect, right? That's why we have them.
this is an interesting thing because like what I see, the reason I'm asking this question of who should do that is because you cannot, you need to have a criteria to also decide how much design you need to do up front, and also how far do you go with that design. And that criteria needs to be aligned with the priorities of the business as well. You need to have a high level picture. Let's say that you have a product, yeah, you're building a software. This software has real needs, like users will be using that, or the internal or external users, doesn't matter, right? So there is a business priorities that you want to understand, and then there are the technical implementation of that. So the question here is like, who should be driving that? What is the role? What part should a developer take in this kind of scenario, in understanding the business priorities and defining technical change within the team and across teams? So that's my question.
What part? Well, the way I see it is that the problem and solution don't cannot live apart, right? So the the problem domain, as it were, or problem space is a part of the solution space, and they actually interact with each other. The solution impacts the problem, and the problem, of course, is impacts the solution. So if, as I mean, everyone should understand things at different levels, but like, for example, for developers who are tasked with creating the solution, if they don't understand the problem, they cannot create a solution. And they need to understand the problem not just at a rudimentary level, or not just at the piecemeal level, like I just need to do this because I'm told to do this. They need to understand the problem holistically. In fact, they need to understand the business, and how what they are creating is serving that business and helping it grow. They even need
I
to understand the strategy going forward, because that helps them understand the design and the places where it needs to flex, because they can look ahead with taking the strategy of the business in
I
mind.
would annotate that because it's not like they cannot create a solution. They cannot create a good solution, or the most effective solution. And this is the problem. Like you can still go and do
You can solve
stuff.
some problem,
Eh,
you just don't know what it
exactly.
is.
It might not be the problem that you think you're solving. No, like, not even, right? So that's the thing, right? Like that perspective. So the question was, who should, what levels of interaction should they have, and who should kind of be involved in that process, either designing it
Yeah,
or
or
to
what
some other
role the
level.
developer
What
should
what
play.
role should they play? No, so as a developer, at least understanding what that vision is, that's number one. Then you can influence that and you can shape it at different levels. Yeah, so maybe if you're in a super big organization, you may not be able to affect that much the macro, but at the system level that you're working on, or even at the component level, you can make better decisions if you understand what everything looks like, right? Or how, or which direction you want to go, technically, or technologically, or whatever, right? So those things can already help you, let's say, make better decisions. So one is understanding to be able to, and then affecting it, and having that vision. You may be able to point out specific details that were not taken into consideration when things were being designed at the macro level, because again, it happened at the point where we knew the least about the system. So now we know a little bit more. You can feed that back into that design process at the greater level, no? And I feel like that's something also that people tend to not do at all, right? Like, either the people that are, let's say, they have the governance over the architecture don't listen, yeah, or people directly don't provide that feedback, or don't even understand how their feedback could help shape that decision, right? And that's also kind of a dysfunction, right? We talked about this when we talked about our architects no, are needed, or I don't remember what the name
Our
of that
architects needed, yes.
exactly, or something like that. But that is part of the issue,
Do we
right?
need
Like,
architects? That
do we
was
need
There you go.
architects?
episode number 5.
Yeah. So again, it's it's that communication aspect that needs to happen as well. But we can have a good conversation if we are not both talking about the same thing. No, if you're looking at the detail and then I'm looking at the mark, that's not going to help, right? We need to have that common that common understanding to be able to have a good conversation.
Yeah, one thing that really frustrates me is when I hear developers saying, "Hey, I don't want to do business analysis. I don't want to understand the requirements. This is not my job. I just want to write code, or I want to do the design and architecture, but I don't want to do analysis." So, and for me, that puzzles me, because how do you think that your analysis or your architecture proposal will be accepted if you don't understand the problem, if you show zero interest in the actual business problem that you're trying to solve? So this for me is such a big mismatch, but unfortunately I still see that very, very often. People saying like, you know what, business analysis is not my job. I don't want to spend all my time trying to understand what we need to do. So if you don't want to spend time understanding what you need to do, the only thing that's going to happen to you is someone is going to tell you what to do. There's no other option. And you will be frustrated because you are going to be trying to do things that no one values because you don't understand what needs to be done. So then you are trying to do things that you feel that is important and no one else agrees with that. Right? So this is what I see a lot. And then developers blame the business that they just don't get it, but they don't make the effort to understand the business. So, because ultimately, like, one thing that needs to be said, the only reason that we build software is to solve business problems. Unless that you are working on your bedroom, just having fun with technology. But like mostly in the working environment, you're paid to do a job, and that is to solve business problems. And if you don't understand that, or if you don't have the curiosity to understand that well, there's no way that your architectural solutions and big designs and ideas will be taken seriously if you are not involved in the business discussions. And also the amount of design upfront that you do needs to be aligned to the next steps of the business as well, because you cannot be analyzing and create a big design architectural strategy to something that the business is not prioritizing. Right?
There's something that's been said in the comments as well, which I think impacts a lot what we're talking about here, which is the rotation in the industry. And
I was gonna say this is a big topic. Maybe we should do a fireside chat on it. Is that the retention?
Should we park
That's
it?
a very, very
then?
good question.
Yeah, that is a very good question. I actually think that's a
That's a fireside chat, isn't it? I mean,
let's write it down and
for people listening, it's
what was the question? I'm just trying to find on the chat here. or the
In order to
comments?
see the impact of design decisions, one has to stay in an organization for some time, but average retention in the industry is decreasing.
Oh, I see. That's from Mohammed as well.
Yeah, yeah,
Cool. Yeah,
yeah.
that's a very good point, Mohammed. That's a good point.
It's one that bears a bit of thinking about, because
It's
actually
basically,
I haven't thought of.
can you learn about the decisions that you're making today if the impact, if you're not going to be there to see the impact that those decisions are going to have? So that's
But
more
the
like,
thing is, we have to deal with this all the time, because this is why I think this is a very good topic for a fireside chat. Because as consultants, right, and often we do get blamed, like, yo, you're not going to be living with the decisions that you make. But
Yeah, you
I
are
think
just an external entity that comes in and then goes away,
and then
right?
exactly,
goes
but it's
away and
actually our
leaves
job
everyone
to
else to
make the
do.
right decisions, so that we as a company, we are living with the decisions we make, because we live on word of mouth and people who recommend us, right? So if we go there and do something that then causes impact that is not desired later on, when we are not there, we will still hear about it and we will suffer from it as well. But we have to deal with that problem, is that often we are on projects for 1 year, 2 years, sometimes longer, but a couple of years, maybe a bit more. A 2 year project in a consultancy world is quite a long project, right? and and then as Mohammed Sufyan said, that you have now the retention, like we were looking at the retention figures in the UK, I think is less than 2 now, right?
It's less than
So
2 years. Yeah.
retention averages are very low in the IT industry. And how is that impacting the decisions and the understanding that people have of systems, and how they can use that understanding to to evolve systems towards the better, right? And that's a big question, I think.
Yeah, so guys, like we've been talking for like an hour now, so let's try to wrap up. So, what would be the final words for this episode? So, is design upfront really a bad thing? So that was the initial question that we started from.
Oh yeah, it's very bad.
If you don't do it right.
Yeah. You must
If
get
you don't do
design
it
all the way. If you build it, they will come.
No, I guess we all agree that some level of design upfront is needed. That going to that the extremes are not good. Yeah, and we tend to see extremes very often. Yeah, and that it really depends on what questions you're trying to answer. Based on that, different levels where you're doing that design are necessary, right? Like, it's not the same if you're trying to scope out a project or see how it fits in the big picture, or make some technology decisions. Yeah, those are different questions that you need to answer, and they require different levels of abstraction for your design. No, and yeah, you need to be aware of that, and then again, I'm kind of summarizing a lot of the stuff that
Mhm.
we so just and then what role do you play as a developer? Well, you need to understand what that big picture looks like, so that when you're making decisions at whatever scope you're working at, you can make the best decisions according to where we're going, right? If you don't have that, you end up with ginger ginger systems. No, ginger shaped systems. No,
I learned a new term today. I didn't know that. So
that's good.
thanks,
That's good.
Mohammed, because I
Me
didn't
too.
know about
Me
the
too.
ginger shape.
Yeah.
Mash,
Um,
final words.
Final words are that design is not aside from creating software. It's part of creating software, and it's another medium in which you express your intent, and that then eventually translates into code. It has strengths and weaknesses, just like code has strengths and weaknesses. So if you don't create that right balance, you have to use all these different tools, and just using one tool for everything obviously is not going to get you there anywhere fast, right? So you have to use the right tools for the right job, right? There are other aspects, like when we talk about classes and all these kind of things and of design, but actually e- exploring the problem space is also part of design, and how you explore it, sketch maps and product backlogs, and all those sort of things that we haven't had the time to talk about. They are also part of design. Understanding the problem is part of design. So all these things matter. And as you said, there is no such thing as business analysis. It's not part of my job.
Yeah, so just like Artemas just put something in there that I would like to add, and is aligned. So he says, like, as a dev, no business context of the problem equals no direction in design. And
Very
this
well
is
put. Yeah.
exactly. This is exactly what I would add. I didn't want to repeat what you both said, but like what I would add is exactly that. Is like if you want to have a seat on the table, if you want to drive changes, if you want to push technical changes, you need to bring something to the table. And in order to do that, you need to understand which problem you are trying to solve. You need to understand what is the business needs, what are the business priorities, and then make sure that the solution that you are trying to provide actually addresses a real need. And if that is the case, then you will have a seat at the table. People will listen to you. But if you're just saying, hey, we should do this or should do that, and no one feels that you are addressing a real problem, it will come to deaf ears, right? So you're just going to be frustrated. You're going to be frustrated and everyone else will be frustrated. So cool. Excellent. So I would like to thank very much everyone that was on live with us, asking questions and making these chats far more enjoyable, because it's really, really cool to go through all your questions, all your comments, and be able to address them as you ask. And for everyone else, if you like this chat, remember to subscribe to our channel, hit the like button, put on the comments which topic you'd like us to discuss, and I hope to see you next time. So thank you very much, everyone. Good night.
Thank you, everyone.
Take care.